Hello everyone. The topic is oxidation of 1 degree and 2 degree alcohol by Jones reagent. Yes, before that we have done PCC, PDC, KMNO4, K2Cr2O7 oxidizing agents for alcohol. Now it's a time to understand Jones reagent with its mechanism. 3 degree alcohol will not react with Jones reagent. That's why I have not written it. Only 1 degree and 2 degree alcohol. So first let's understand what is the composition of Jones reagent, how it is generated in lab. For making Jones reagent, the very first reagent that we required, chromium trioxide, in which chromium is making 6 covalent bonds with 3 oxygen, sharing 6 electron. And as you know, oxygens are more electronegative than chromium, so these 6 electrons are passing toward oxygen. That's why this chromium is carrying partial plus 6 charge. It's an orange color compound. Now in this orange color compound, we are going to add concentrated sulfuric acid with some water. That reaction is highly exothermic. Lot of heat energy will be released out, which can decompose chromium trioxide. So to control that lot of heat energy, we are using ice bath. Means you have to mix them in ice bath, which will maintain a temperature of 0 to 5 degrees Celsius. The reaction is highly exothermic. So to cool down temperature, we are using ice bath, which will maintain temperature of 0 to 5 degrees Celsius. Now what is the mechanism? As you know, acids will provide us H positive particle. These H positive particles will attack on, these are electrophile, wants electron. Who can provide electron? Oxygen with pi electron. So it will attack on oxygen and pi electrons will shift toward oxygen side, due to which chromium will get vacant orbital, positive charge, which will be satisfied by OH negative, which are coming from H2O. So this will be the first attack. H positive, electrophile, wants electron. Which electron? Pi electrons. Obviously pi electrons are more closer toward oxygen, so it will attack on oxygen. Bond will break, electron will shift toward oxygen. These electrons will be used by oxygen to make bond with hydrogen, due to which on chromium vacant orbital will generate with a positive charge, which will be filled by OH negative, which was generated from H2O. So we will get these two oxygens as it is. Here we will have OH and this O will turns to OH. Out of 2, 1 bond will break and will join with H. Chromic acid. Chromic acid will generate orange yellow color solution. In this chromic acid, we will add acetone as a solvent plus water, H2O. So this whole mixture, this chromic acid, when will be added in acetone and water, this mixture is known as Jones reagent. And this whole Jones reagent will work in the range of 0 to 25 degrees Celsius temperature. Please note down this temperature. It is a very important to understand its reaction. Now, after this preparation method, let's check how this Jones reagent, and in Jones reagent, let me repeat again, who will work as oxidizing agent? This chromic acid. This chromic acid will do oxidation of alcohol. These are solvents, acetone, water, they are solvents. Temperature on Jones will work 0 to 25 degrees Celsius. Now let's check how it will oxidize 1 degree alcohol. Let's understand mechanism. It can oxidize 1 degree alcohol first to aldehyde and then to carboxylic acid. This is 1 degree alcohol, general formula. This is chromic acid. I think we have done this mechanism earlier also. Yes. Where? When I have oxidized alcohols with K2Cr2O7 and H2SO4, potassium dichromate, chromic acid was generated, and here also chromic acid is generated. So what do you think? Mechanisms will be different? No, mechanisms will be same. Only the point is, here chromic acid is generated from a different way, and here chromic acid will generate from these reagents. Mechanism will be same. So now listen very carefully. I'm not going to tell you the whole mechanism. Please check the video where we have understood K2Cr2O7 sulfuric acid reagent for oxidation of alcohol. Same mechanism is there. Chromic acid is generated. It will oxidize 1 degree alcohol first to aldehyde. Then aldehydes will become hydrates of aldehyde. They will further react to finish up to carboxylic acid. And during these reactions, one intermediate will generate chromate ester. Now the main point is, which I want to understand, is this. When we react with 2 degree alcohol, you know, 2 degree alcohol will oxidize up to ketonic stage. Mechanism, please check. Same mechanism, K2Cr2O7. Don't say sir has not told us the mechanism in this video, because we have done this mechanism already in K2Cr2O7. Same mechanism it is. Now ketone will generate. Ketone will not oxidize further in Jone's reagent. Now this is the point. When I have used K2Cr2O7 H2SO4, my ketone was oxidized further to carboxylic acid. But when I am saying Jone's reagent, ketone will not oxidize further. To understand it, first we need to understand how ketones oxidize. Mechanism already I have told to you. Actually, ketone will convert itself to enol first. Enol in acidic medium. And that enols will be further oxidized to carboxylic acid. Plus alcohol will also there, which will further oxidize to finally carboxylic acid. Here, ketone is not able to produce enol. You will say, in Jone's reagent also the conditions are acidic. How you have created Jone's reagent? CrO3 plus H2SO4. The acidic medium is there. Then why not ketone is converting itself to enol? And here K2Cr2O7 acidic, it is converting itself to enol. Here we have a role of temperature. That's why I said please keep temperature in your mind. When we are oxidizing with K2Cr2O7 and sulfuric acid, we are heating it. The high temperature leads the conversion of ketone to enol. But in Jone's reagent, you can check what temperature I have used. I said 0 to 25 degrees Celsius. This temperature will not allow ketone to convert into enol. And you know, enols are less stable forms as compared to ketone form. Ketone forms are more stable as compared to enol forms. So 0 to 25 degrees Celsius is a very low temperature, will not provide sufficient energy for the conversion of ketone to enol. But here on heating, we can convert ketone to enol, and enol will be further oxidized. This is the point where Jone's reagent is differ from K2Cr2O7. Jone's reagent can't oxidize ketone further because of its less temperature condition. Less heat is available. But K2Cr2O7 can convert ketone further to enol, and enols will further oxidize to carboxylic acid due to its high temperature. Same for 3-degree alcohol. We know K2Cr2O7 can oxidize 3-degree alcohol. How? In acidic medium, firstly it will show dehydration. Please check the videos. You will find out everything is given there. Again and again, I am not going to write every mechanism. Same mechanism it is, if it is there, no need to write it again and again. 3-degree alcohol in acidic medium will first show dehydration and will create alkene. And these alkenes will be further oxidized to ketones or aldehyde depending on the condition of alkene. But here you will say 3-degree alcohol, acidic medium is there, but dehydration is not happening. This dehydration will not happen to create alkene. And if alkene will not generate, how further oxidation is possible? So the point is, why dehydration is not happening in the acidic medium? Again the same answer, temperature. This very low temperature will not allow dehydration of alcohol to alkene. Because we know for dehydration of alcohol to alkene, what temperature is required? 433 to 443 Kelvin temperature range is required, which will be available here on heating. But in Jone's reagent, we are not increasing temperature beyond 25 degrees Celsius, 0 to 25 degrees Celsius, the normal room temperature. Due to this very low temperature, the 3-degree alcohol will not show dehydration, and it will not convert itself to alkene. And if alkenes will not generate, further oxidation is not possible. But whereas in K2Cr2O7, we are heating it, that will provide sufficient heat for the dehydration, which will turn 3-degree alcohol to alkene, and alkenes will be further oxidized to ketone or aldehyde depending on the nature of alkene. That's it. This is the end of the video. These were the important points. Rest mechanism is same. Chromic acid is there. Once in short, I am telling you. Chromic acid, positive 6, electrophile, oxygen will attack, pi electrons will break. This is 1-degree alcohol I am using. Oxygen will become unstable, negative OH. What will release out? H positive. These H positive can attack on O negative, which we call intramolecular hydrogen transfer, or they can be attacked by base. H2O will provide us H positive, OH negative. This OH negative can attack. That mechanism we know. After this, removal of this H, the intermediate which will generate, that we call chromate ester. This chromate ester full of oxygen, highly electronegative, So it is attracting electrons from carbon side. In turn, carbon is attracting electrons from its hydrogen. That's why these hydrogens are becoming highly positive, acidic, which in turns will be attacked by OH negative particles, due to which carbon hydrogen bond will break and it will transfer its bond with oxygen, due to which this bond will break and electrons will be further pushed. Please check this. RCH double bond O aldehyde will be generated. So this mechanism already we have discussed. So please try. And this is the end of the video. In next video, we will understand Collins reagent, the final reagent. Thank you very much.